Hi everyone, I'm going to work some selected problems on our review for Unit 3 to help you prepare for your test. So starting off with number 1, I always recommend rewriting these equations so that a square root is represented as something to the 1/2 power. That way it's a little easier to see what you're going to be taking the derivative of here. So remember, this is going to be a chain rule. My outside function is the 1/2. Then I have sine, and then I have 2 theta. So this is going to be a double chain rule right here. So we're going to start with the 1/2. So I'm going to put 1/2. Remember that we leave the inside as is. So sine of 2 theta is going to stay on the inside. And then I'm going to decrease this by 1 to get negative 1/2. So we did the derivative of the outside times derivative of the inside. So derivative of sine is cosine. Leave the 2 theta. Times derivative of the inside of this one, which is just 2. Now we're just going to simplify a little bit. I have a 1, this is all multiplied together. So 1/2 times 2, that's just going to be 1. I can cancel those out. A negative exponent, if you remember, that means that it goes to the denominator, and this is a square root. So this is going to be my numerator, and my denominator is going to be the square root of sine 2 theta. Right, number 3. I'm trying to do the derivative here with an e. Remember, e is derivative of the stuff, so whatever this exponent is. So negative 4 is just a multiplier. We don't have to worry about that. Derivative of secant. So that's our little box, the tan secant secant. So the derivative of secant is tan secant. So it's going to be tan x secant x, that's the derivative of the stuff, times e to the stuff. So times e to whatever is up there, we just leave it there. That one doesn't really simplify any, so we can just leave it like that. Number 5. Okay, we have an implicit here because I've got some x's and y's, and I'm taking the derivative with respect to x. So I'm going to do the derivative one at a time. So the derivative of this is just 2x. dx remember is 1, so we can cancel, leave that out. I have a product rule right here. So the first times the derivative of the second, so that would be 1 dy dx, plus the second times derivative of the first, that's just 1, plus the derivative of this is 2y dy dx, and the derivative of 3 is just 0. Okay? Now we want to find dy dx, so I need to rearrange my equation so all the dy dx's are on the left and everything else is on the right. So I'm going to put the negative 2x over here. This one is staying on the left. This one I'm going to subtract over here. This one has a dy dx, so I'm going to leave it over here. Now I'm going to factor out a dy dx. Final, to get this by itself, I just need to divide by this. Okay. Number 7, what is the average rate of change of the function? So that is AROC. To find AROC, we just do, this is like your y2 minus y1 all over x2 minus x1. So just need to figure out what f of 3 is by plugging into my function here. So 3 to the 4th. 3 times 3 is 9. So 9 times 9 is going to give me 81. So that's 81 minus 5 times 3, I know, is 15. So when I subtract those, I get 66. Okay, so that was this number. That was my f of 3. F of 0 is just going to be 0. And that's over 3. So that reduces to 22. Number 8. Selected values of the increasing function h and its derivative, h prime, are shown in the table. If g is, that means equals, the inverse of h, what is the value of g prime? So g is the inverse of h, so that's this relationship. So if I want to find g prime of 7, since this is an inverse, the derivative of an inverse is always 1 over the derivative of the inverse. Okay, so the inverse at 7, so I'm looking on the h graph where the y value is 7. On the h graph where the y value is 7, the x is 3, so that's the inverse here. So 1 over h prime of 3. Now I'm looking for h prime of 3, which is 5. All right, I'm trying to find f prime of 0. So first I need to find f prime. Remember, this squared is on the outside. In fact, I always say to rewrite it first. So sine of 3 minus x squared. So rewrite it like that first so that you can see that the outside function is the squared. So when I do the derivative, the 2 is going to come out front. Leave the inside, decrease this by 1, times the derivative of the inside, and times the derivative of the inside. Double chain rule here. To simplify, you can just multiply these together because it's all multiplied. Sine of 3x and cosine of 3x. Oh no. I accidentally just changed that to 3x, didn't I? It's supposed to be 3 minus x. Let's tweak this a little bit. 3 minus x. 3 minus x. Okay, so then what would be the derivative here? Well, 3 would be 0. Negative x would be negative 1. Okay. Alrighty, so let's tweak this now. This would be negative 2, and the rest would be the same. Okay, that looks good now. Number 10. Here's h. Write an EOT, equation of the line tangent to h at the point where x equals 1. So whenever we write the EOT, we need to start with the POT. So h of 1 is what we're looking for our point. So that means I'm going to do sine of f of 1. F of 1 is 3 pi over 4. So 3 pi over 4, I'm thinking about my unit circle. Half is straight up, so 3/4 would be this way on the unit circle. It's this coordinate right here, right? Right here. And so sine is the y value there. The y value is going to be positive root 2 over 2. Don't forget to look over your unit circle before the test because those always pop up. Okay, so my SOT is going to be the derivative. So the derivative of this is cosine, leave the inside, times derivative of the inside. Now we want to evaluate that at 1. So cosine, so f of 1. F of 1 is 3 pi over 4. And f prime of 1 is root 2. Okay, so cosine of 3/4, that's the same coordinate here, but the x value is also root 2 over 2, but we know the x's are negative over here. So this is going to be negative root 2 over 2 times root 2. So when I multiply those together, root 2 times root 2 is just 2. So negative 2 divided by 2 is negative 1. Okay, we can write our equation now. Y minus root 2 over 2. My SOT is negative 1. X minus 1. Number 11. Find dy dx. So we're doing the implicit derivative here. Right off the bat, I have a product rule right here, so I'm going to do the first times the derivative of the second, which e to the x is just e to the x, plus the second times derivative of the first, which that would be 1 dy dx. Derivative of negative x is just negative 1. Dx over dx would cancel. And then this would be 2y dy dx. Since I'm solving for dy dx, I want to get all my dy dx's to the left and everything else to the right. So I'm going to organize everything here. I put this one over here. This one stays. This one I'm going to add over here. This one I'm going to subtract to the other side. Okay, now I'm going to factor out my dy dx. And we're going to divide. All right, number 12. Oh, same thing, implicit derivative here. So I'm going to do 2x. I have a product rule here. First times the derivative of the second plus the second times derivative of the first. Derivative of y squared. Derivative of 1 is 0. Okay, now I'm going to organize. My dy dx's, I have an x and I have a 2y. On the other side, I'm going to move the negative 2, the 2x over here, subtract it over, and I'm going to subtract the y. Divide. Find an expression for dy dx in terms of x and y. That means, when it says in terms of x and y, that just means you're going to have x's and y's in your final answer. Find all x values on the curve where the tangent is horizontal. So a horizontal tangent tells us that we're looking when dy dx is equal to 0. And we're trying to find the x values where that happens at. So I want to see where this equals 0. First point on your test would be at some point showing that it equals 0. Now I could multiply this times both sides, and that's going to go away. And I'm not able to finish solving this. So I'm going to have to go back to my original equation here. I'm going to have to plug this in. I could either plug in for x or for y. Let's see which one would be easier. I think it would be easier to isolate y here. So if I add y to the other side, I'm going to plug this in for y in my original equation. So I'm looking at my original equation here. Instead of y, I'm going to plug in negative 2x. I'm essentially creating a system of equations here. And then I'm plugging that in for y. So I took both of the y's, I put this in place, because now I just have x's. Now I can solve for x, and that was my essential goal, was to find the x values on the curve. So let's simplify a little bit here. This is going to be negative 2x squared. This will be 4x squared. So that's going to be negative 2x squared plus 1 more is 3x squared. Divide by 3 and square root it. So when I square root, it'll be plus or minus the square root of 1/3. And there's all the x values. So I guess we have two x values, positive square root of 1/3 and negative 1/3. Or you could also put plus or minus 1/√3. That would be the same answer. Either one would be fine. Okay, I'm going to skip down to number 16. I notice I have a chain rule here to find the derivative. The outermost function is this 4, so I'm going to do that one first, and then I'm going to leave the inside. Decrease that by 1. So I did the outside function. I multiplied, decreased it by 1. I left the inside the same. Now I'm going to multiply by the derivative of the inside. So I'm going to start with this one. The derivative of this is derivative of the stuff times e to the stuff. Derivative of negative sign is negative cosine. But then I also have to do derivative of this times 2. Okay. And now we're going to simplify a little bit. Not much simplifying I can do, really. I mean, I could put this 2 out front, but really nothing else I could do. So I'm just going to leave it like that. Number 19. Consider this curve for y is greater than 0. Show that dy dx is this. So this is just, can you do your implicit derivative and show that it ends up equaling this? So we're going to start with 2y dy dx. We have a product rule here. So I'm going to have the first be my negative x squared. So the first times derivative of the second plus the second times derivative of the first and the derivative of 6 is 0. Okay, dy dx is to the left, everything else to the right. 2y, I'm factoring out the 2y, and for this one I'm factoring out the negative x squared. This is going to move to the other side. Since it's a negative 2xy, I'm going to make it a positive 2xy over here. Okay, so dy dx is this, and then we're going to divide by this. And I always check to make sure I landed in the same spot. Sometimes I have to switch my terms around, but that looks good, and they even did the 2y first. So I just, in the end, make sure that my answer matches this exactly. If not, rearrange it so it does. Write the equation for the line tangent to the curve. EOT problem. So we start with our POT, which they gave us. SOT, so the slope of the tangent line. Well, this is my slope, so we have this. dy dx evaluated at 1, 3 is going to be 2 times 1 times 3 divided by 2 times 3 minus 1 squared. So that's going to be 6. 6 minus 1 is 6/5. So we have enough to write our EOT now. Y minus 3. My slope is 6/5. And then x minus 1. Part C, show that there is a point P with x coordinate 0 at which the line tangent to the curve at P is horizontal. So again, show that dy dx equals 0 when x is 0. So we've kind of got two things to show here. My dy dx, okay, I want to show my slope is 0, that's the horizontal slope, when my x is 0. So I'm going to go ahead and plug in 0 for my x here. So I get 0 over 2y. Okay, so as long as y is not 0, we do have a horizontal tangent, okay? But I need to go back to my original equation here, up at the top, and make sure that this is a point on the curve. We need to get the y value still, okay? So I'm going to go up here, y squared. I know my x is 0. Okay, so this is going to be 0. So I have y squared equals 6. Square root that. I get plus or minus the square root of 6. Okay, so we're getting closer. We have some y values. Show that there is a point P with x coordinate 0. The line tangent is horizontal. Find the coordinate of P. So I'm trying to find the coordinate. One note that I have though here up top, it says that my y value is greater than 0. So my y value cannot be negative 6. But my y value can be positive root 6. So we have a horizontal tangent at 0 root 6. Also keep in mind we could have put the root 6 right here and we would get 0 root 6. It would give us a 0 slope, so that checks out. And we plugged it into our equation to prove that that point does exist on the curve. All right, part D is the second derivative. This will be a free response question, and so since we're trying to find the second derivative, we're starting with our first derivative here. This is going to be a quotient rule. Be sure to show your first step of the quotient rule. I'm looking for low, D high. So the derivative of this is going to be a product rule. You've got 2x as your first and y as your second. So the first times the derivative of the second plus the second times the derivative of the first. Okay? So this was low, D high, minus high, D low. Okay, derivative of that is 2 dy dx minus 2x. All over low squared. Okay, so first step is showing that you did your quotient rule properly. Second step is plugging in and getting a value. So I am plugging in at the point P. So my point was this. This is what I'm plugging in for x. This is what I'm plugging in for y. And when I come across a dy dx, I'm going to need to figure out that number too. So dy dx at 0 root 6. That is going to be 2 times 0 times root 6. So that's going to be 0. 2 times root 6 minus 0. Okay, so where did we land? That's 0 on top, and this is over 2 root 6. So this is just going to be 0. So anytime I come across dy dx, I'm going to plug in 0. Okay, so now we're ready to plug in. My y value is root 6. My x is 0. 2 times 0. This is also 0, so I'm not going to even write that because that's going to all be 0. 2 times my y, which my y is root 6, minus 2 times 0 again times root 6. So that part's going to end up being 0. 2 times 0 again, minus 2 times 0 is still going to be 0. At least the lots canceling out when we're plugging in. And 2 times root 6 minus 0 squared. All right, we should be able to eliminate a lot now here. 2 root 6 times 2 root 6 is 4 times 6. This is all 0. And this squared is going to be 4 times 6. Wow, the whole thing is 1. How fun is that? 24 divided by 24 is 1. Yay! Okay, 21. If g of x equals the inverse of x, what is the value of g prime of 4? Well, since that's the inverse, since we're trying to find the derivative of an inverse, it's 1 over the derivative of the inverse. So first I want to find the inverse of 4. So that means I'm looking for the y value on f. That's 4. Here's f. There's a y value of 4. So the x value is negative 2, which means I'm now looking for f prime of 2. F prime of 2 is 1. 1 divided by 1 is 1. Oh, wait, hold on. Did I do that right? F prime of negative 2 is 4. Oops. There we go. 1 over 4. 22. So we're doing the second derivative here. So we need to find the first derivative and then the second derivative. We've got 2 steps here. So we got to remember our E derivatives. Remember, that's derivative of the stuff. So the derivative of x cubed is 3x squared. So that's derivative of the stuff times e to the stuff. So that's my first derivative. My second derivative means I do that again, which I now have a product rule. So I have the first times the derivative of the second plus the second times derivative of the first. Let's see if we could simplify this any. Well, I could distribute this, multiply these together, so this would be a 9x to the 4th plus 6x. Well, these are not like terms, so I can't exactly combine them, so I guess that's as far as I can simplify. Turning to number 26, we have an equation when y's are greater than 0. Show that dy dx equals this. So I'm going to do the implicit derivative, and my goal is to land here. So I'm going to start with this derivative. That's 4y dy dx. The derivative of negative 6 is just 0. Right here it looks like I'm going to have a product rule, y times sine x. So the first times the derivative of the second plus the second times derivative of the first. Okay, now I'm going to organize. I would like to get my dy dx's on the left. This one needs to come over here. So when I move this over here and factor it out, I'm going to have a sine x over here. Okay, now I just need to divide by this term to get what dy dx by itself. Now I'm going to check to make sure I landed in the right spot. Ooh, I have a minus. What did I do wrong here? Let's see. Oh, when I moved this to the other side, this should have been a subtraction. So that does make sense. Okay, now I do match. See how that is kind of nice that you get to see the answer to see what you did wrong. Caught myself, so that was good. Okay, B. Write the equation of the tangent line. We've got an EOT problem. They already gave us the POT. So to find the SOT, we have our derivative dy dx. We just need to evaluate it at 0 root 3. So my y is root 3, cosine of 0, 4 times root 3 minus sine of 0. So cosine of 0, I'm thinking about this coordinate straight over. The x value there is 1. So 1 times root 3 is root 3. my y value at 0 is 0. So this is just going to be left with 4 root 3. So when I have root 3 divided by root 3, that's going to cancel. I'm just going to have 1 over 4 here. Okay, so I should have enough to write my equation now. Y minus root 3, 1/4, x minus 0. Okay. I hope you can figure out the rest by looking at my key. If you have any other questions, let me know. Good luck on your test. I hope you do awesome.